This is the video for problem 6-67 from the H6-3 curve fitting applications lesson. If you're needing help with this problem, that's why you're watching the video. So listen along and hopefully we'll help you with whatever problems you're having. It states, sickly Sid has contracted a serious infection and has gone to the doctor for help. The doctor takes a blood sample and finds 900 bacteria per cc, which is cubic centimeters, and gives Sid a shot of a strong antibiotic. The bacteria will continue to grow for a period of time, reach a peak, and then decrease as the medication succeeds in overcoming the infection. It says after 10 days, the infection has grown to 1,600 bacteria, and then after 15 days, it has grown to 1,875. Okay, so this is like, real life scenario. You know that when you get sick and you go to the doctor and you get antibiotics, okay, whatever sickness or illness you have is spreading and growing, and the antibiotics have to slow it down and get it to stop, and then it can start killing it off. So you don't get better instantly. It usually takes a few days for it to kick in, and get the bacteria to stop growing, and then it starts killing it off there. So, letter A says name 3 data points given in the problem statement. All right, so to do that here, let's see here. We're gonna have to kind of define some variables here. Let's let x equal, okay, so he went in there, the doctor got a blood sample. So let's let x equal time since the doctor's appointment. Okay, so that's when he initially was like diagnosed. And then our y value should represent the amount of bacteria. Okay, so now we're not just like making weird ordered pairs that, maybe don't mean something, okay? Now we know what the x's mean and what the y's mean. So if Sid went to the doctor and, that would be like when we were starting. So we'll say that Sid, that's like 0.0 there, right? That's our starting value. We know that when he went to the doctor, he had 900 bacteria in his system. It then says after 10 days, the infection has grown to 1,600 bacteria. All right, so we've got after 10 days after going to the doctor, he's now at 1,600 bacteria. And then after 15 days, it's at 1,875. So we got 15, and then that would be 1,875. All right, so we've got our 3 data points. Letter B says make a rough sketch that will show the number of bacteria per cubic centimeter over time. Okay, we can do that. Let's just do this. Let's set up our x and y axes here. So we know that this is time. Our x is time. And I think we were doing that in days. And then our y values, right? This is like our y-axis. We said that that was going to be our number of bacteria. And I think we were saying per cubic centimeter. That's not as important out on there. Just know it's the number of bacteria. So, all right, so we think about it here. At 0, remember it was like 900. So, it's not going through the origin. It's somewhere over here, right? Like if we said this was like 900, and I don't have enough room to write the 900 there, but I can make some room. Just move that over a little bit. All right, let's just think about that. So this was like 900. This is just a sketch, so you don't have to be like super accurate on it there. And then we know after 10 days, right, it said it had grown. So we'll just say this was like 10 days here. It had grown to like 1,675. I'm sorry, 1,600. It was the next one of the 75. And then just 5 days later, it didn't grow as much, right? So it's something like that. We'll say that was like our 1,875 at like 15 days. Okay, so you can kind of see the growth that's happening, and eventually what we want there, right, is for it to stop growing and then hopefully come back down, to where, he's down to 0, and there's no more bacteria in his system. Well, let's see how long that takes. Okay, so hopefully you understand the scenario, the situation that's happening. Let's look at C. It says find the equation of the parabola that contains the 3 data points. So this is a great opportunity now that you know what's going on. If you want to pause the video here and try to come up with these equations on your own first. Okay, I'm going to go through it now, but please use the power of the video to make sure that you're understanding. So I'm going to start out. We know that this is a quadratic, right? It's a parabola that's opening down. So we're going to be using that standard form. And then we're going to be using each of these 3 points up here. We've got this one, and this one. I'm going to start out here. Let's do our 0, 900. So we know 900 is our y. And then we've got a times 0 squared plus b times 0 plus c. And then let's do the second one. We've got 1600 bacteria, and that would be a times 10 squared plus b times 10 plus c. And then we'll do our third one here, which was the one that had 1875. We have a times 15 squared plus b times 15 plus c. And we'll just go ahead and simplify each of those. Now this first one is nice because, right, we're using 0. 0 squared, right, is 0 times a is 0, and then b times 0 is 0. So this is another one, if you did that first problem already, real nice because we get the c value already. It's not always like this, but when it is, it's really nice. So c is 900. Now let's go ahead and simplify the second one. So what we've got here is 10 squared, right, would be 100. So we have 100a plus 10b plus c should equal 1600. And we'll do our third equation here. 15 squared, we know is 225. And then we have plus 15b plus c is going to equal 1875. All right, so I'm going to move this up a little bit so we can see what we're doing. And I'll go ahead and just label these equations. This is equation 1, 2, and 3, so I can refer to them a little bit more easily. And remember, when we've got this c value already, we can go ahead and just plug it in for the c's in these equations, and then we have 2 equations with 2 variables. So that's going to help us out a tremendous amount. Let's go ahead and do it here. So we're going to plug in that 900 for c, and then I'm going to simplify them, just like we did in that first problem if you watched it. All right, so for our equation 2, right, we're just taking it here. We've got 100a plus 10b plus 900 equals 1600. And I'll go ahead and subtract the 900 from each side. So that equation is now going to be 100a plus 10b is equal to 700. And you know what? Let's make this even easier to work with, right? All of these numbers end in 0, so they're all divisible by 10. So if we multiplied everything times 1/10, or said we were dividing everything by 10, we can make this equation a little bit more manageable to work with, right? We're going to get 10a plus b is equal to 70, right? That's the equation 2 that I'm going to box in. This is the one that we want to use since we have 2 variables in it, and we'll use it to help us find our a's and b's in just a moment. Let's go ahead and do that same thing here with equation 3. Right, this is the green equation. We've got 225a plus 15b plus 900 is equal to 1875. We'll subtract the 900 from each side. So that's going to end up giving us 225a plus 15b is going to equal, and I believe that should be 975, right? And if I'm not mistaken, I believe that all of these numbers are divisible by 15. So let's just make this equation smaller and easier to work with as well. Let's just divide everything by 15. I hope 975 is divisible by 15. Let's check it out. So I know that 225 is 15 squared. So I know that that one is 15a. And I know that our b is going to work there, right? So it's 15a plus b. And let's see, 975 divided by 15. Yeah, 65. There we go. Right? These numbers are much smaller and easier for us to work with. So we got that there. So that's our equation 3. You don't have to do that. I'm just trying to give you some pointers there because it might make things a little easier. And you notice in both of these, right, you've got a b, so that's going to make the elimination really easy to do. Let's take it here and let's use our equation 2 and 3. I'm going to multiply my equation 2 by a negative 1. Okay, so I'm going to have a negative 10a minus b is going to equal negative 70. And then I'm going to use my equation 3 just as it is. We've got 15a plus b is going to equal 65. And now we'll take it and do our elimination. Right, that's going to leave us with 5a is going to equal negative 5. And therefore, right, we divide each side by 5, we're going to get a equals negative 1. Let's take that, plug that back in. Let's go, we'll just plug it into equation 2. So we've got, this is equation 2 I'm using, just so you're aware. We've got 10 times negative 1 plus b is going to equal 70. That's a negative 10 plus b equals 70. So we're going to add 10 to get b equals 80. And then we just need to find our value for c. So, oh wait, we already have it, right? C equals 900. So we should be able to write our equation. I'm going to write it up, I'll write it up above here, right? This is going to say y equals, so a is negative 1. So we have a negative x squared plus 80x plus 900. And if you see here, that makes a lot of sense because this parabola that we've sketched here is opening down. So we know that a must be negative. So it matches up with what we're doing. All right, so now that we have our equation, let's see what else it asks us to do. It says, based on the equation, how long will it take until the bacteria are eliminated? All right, so let's think about it here, okay? If when the bacteria are eliminated, we're thinking about when are there 0 bacteria? We want to know when are there 0 bacteria. So let's take our equation that we have, right? Our new equation that we've got right here. And remember, our number of bacteria is our y. So we want to make sure our y is equal to 0. We're going to say 0 equals negative x squared plus 80x plus 900. Now, I know in my classes we don't normally factor things that have a negative x squared. So you have a couple options. You can either take everything and move it over to the other side of the equation, or just multiply everything times a negative 1, which will end up flipping all of your signs. It's still going to equal 0, but it'll be x squared minus 80x minus 900. It is the equivalent. It will still touch the x-axis in the same places. So this should factor, right? We've got, let's see, x and x plus and minus, right? Because it's a negative 900. And I know 90 times 10 has a difference of 80. So it looks like I need more negatives than positives. So this would be x minus 90 and x plus 10. And then we'll set each of those equal to 0. And we get x equals negative 10 and x equals positive 90. Okay. So the question says, based on the equation, how long will it take until the bacteria are eliminated? Well, if he visits the doctor right here at, that 0th day, and this is 90, right? It's going to take 90 days to get rid of all of the bacteria, right? The -10 wouldn't make sense because that's going to go back in time, right? It's going back in time. But that may come up here in that next problem. So let's write down our answer for this one first. It will take 90 days to eliminate the bacteria. So then letter E says, based on the equation, how long had Sid been infected before he went to the doctor? That's where our other answer comes into play, right? Because it looks like he was at 0. He was at 0 bacteria back here. This would have been 10 days back, right? Because this is the value -10, right? So, but we're on the x-axis, which means the y value is 0. So Sid had been infected for 10 days before he went to the doctor. And now he's all better. All right, so hopefully that helped you and that made sense with this problem. If you got it, good. If you have questions still, please make sure you reach out. Thanks for watching.